Alright, in this video we're going to talk about 6.4 Day 1 hyperbolas. So as you can see, the definition of a hyperbola is similar to that of the ellipse, but instead of having the sum between the distance between your two foci being constant, now it's going to be the difference. So looking at the picture off to the right, D2 minus D1 is going to be the same no matter where you fall on the hyperbola. So it kind of looks like you can either think of it as an ellipse that you cut in half and then flip inside out, or it kind of looks like two different parabolas. The standard equation is going to be very, very similar to that of an ellipse with a couple key differences. The first key difference is the fact that we have that subtraction, right? We're talking about a difference this time instead of the sum. So it's going to be x minus h squared over a squared minus y over k squared over b squared equals 1, or y minus k squared over a squared minus x minus h squared over b squared equals 1. So that's the biggest difference, is the minus sign. The next difference is the fact that since it is subtraction, the order in which the x or the y comes first is going to be significant. So if the x comes first, it's going to have a horizontal transverse axis, and that just means the line that's going to contain the center, the vertices, and the foci. So a horizontal one looks like this, so it's going to open up to the right and the left. So if x squared comes first, we're going to open up like this. If y squared comes first, we have a vertical transverse axis, which means we'd have a focus here, the vertex here, the center here, another vertex, another focus, and we're going to open up vertically. Everything else, with one more small exception, is going to be pretty much the same. So the distance from the center to a vertex, like they have listed here, is still a. The distance from the center to a focus is still c, except this time a is going to be smaller than c. B is going to work the same way going up this way, or vertically it's going to go out this way. And the relationship between a, b, and c this time is going to be the Pythagorean theorem. So last time it was a squared minus b squared, this time it's a squared plus b squared. So the big difference is the order in which your x and your y show up is important. A squared plus b squared equals c squared. And we didn't really mention it, but since the order is the one that's going to be important, a squared, or a, doesn't have to be bigger than b anymore. It's whatever comes first is the way we're going to open. So let's look at an example real quick. And it's find the standard form of the equation with the hyperbola with foci at -1, 2, and 5, 2, and vertices at 0, 2, 4, 2. So to start, let's just kind of throw these things on a real rough sketch, kind of see what we have going on here. So if we have vertices at 0, 2, so 1, 2, there's a vertex. 4, 2, 1, 2, 3, 4, 2, there's a vertex. The foci are going to be -1, 2, so -1, 2, and 5, 2. So based on this, we can tell that we have a horizontal transverse axis, which means our x squared term is going to come first. We're going to open up this way. So a rough sketch looks something like that. So we can figure out a and c pretty much the same way we did before, right? We know the center is going to be right in the center. So right in between, halfway between your two vertices is going to be the center. So if our vertices are 0, 2, and 4, 2, our center is going to be 2, 2. So we know the center is 2, 2, so we can say x minus 2 squared over something minus y minus 2 squared over something equals 1. So to find out what goes under these things, our a squared and our b squared, we have to take advantage of the relationship squared between a, b, and c. So a, b, and c are going to work the same way as they did with ellipses. It's just the distance from the center to either the vertex or the focus. So we can look at our picture from the center 2, 2 to one of the vertices 0, 2. We know a is going to be 2. The distance from the center to 2 to a focus, negative 1, 2, is going to be 3. So if a is 2, c is 3, we can plug those things in here, and we're going to get 4 plus b squared equals 9. So b squared equals 5. We don't really need b because we're going to put b squared under here, but b would end up being the square root of 5 if you wanted to go ahead and find it. But since we know we're going right and left 2 spots, a is 2, a squared is 4, 4 is going to go under here. We found b to be, or b squared rather, to be 5. So we have that equation right there. So this is an example of our b actually being bigger than our a, and that's okay. We don't really care for that. That's only important for ellipses. What's important for the hyperbolas is that since we're opening with a horizontal transverse axis, that we have our x squared first. So that's writing the equation. Again, very, very similar to ellipses. And we're going to kind of change gears. We're not going to talk about graphing yet. That's going to be in another video. But what we're going to look at now is the relationship between all of these conic sections written in a general form. So we've seen all the standard forms for parabola, ellipse, hyperbola. In your geometry class you saw the standard form for a circle. But we can write all of those conic sections in terms of our general form. Ax squared plus cy squared plus dx plus e plus f equals 0. Now we could go through, complete the square for everything, and then figure out what it looks like and figure out from there which conic it is. Or we can kind of look at the numbers that are attached to our squared values. So if a and c are the same thing, then we're going to end up having a circle. If they say a times c equals 0, but over on to the right in the red it says if a equals 0 or c equals 0, then we have a parabola, and that just means we don't have one of the square terms. We either have an x squared or a y squared. An ellipse is going to be if your product of a and c is greater than 0, provided that a is not equal to c. And then if you have a hyperbola, a times c is going to be less than 0, and again that's provided that a and c are not the same number. So let's look at a real quick example of figuring out what conics are without actually factoring anything. So if we look at this one, a is 4, there's no y squared, so our c is going to be 0. So if we only have 1 squared, this has got to be a parabola. Looking at b, we have a 4x squared and a negative 1 y squared. So if we think about that, we say, well, 4 times negative 1 is negative 4. That's less than 0. So if we're less than 0, then we have a hyperbola. Looking at the next one, we have positive 2x, positive 4y squared. So we can say 2 times 4 is 8. That's greater than 0, so we have an ellipse. And looking at this one, we have 2x squared, 2y squared. They're the same number, so since a equals c, or in this case 2 equals 2, we have a circle. So that's going to do it in this video. We'll see you in the next one.